Hello everyone, I'd like to welcome you to this video titled Understanding Percent, and you'll need to turn your Go Math book to page 203, get out your math journal and a pencil. For this video, the goal is for you to find a percent of a quantity as a rate per 100. So basically what we're going to look at is how you can write a ratio as a percent. So one of the key things to understand on page 203 is that a percent is a ratio that compares a number to 100. It's always 100. Okay, the symbol percent is used to show a percent. Okay, this symbol right here is used to show a percent. So for example, 17% is equivalent to 17 to 100 ratio. Okay, so everything is always per 100. Okay, so even if it's just 4 objects, it's not the objects that you're looking at, it's the percentage. Okay, so it's always compares a number to 100 there. So let's take a look at some of these different types of ratios, and let's take a look at them as percentages. So the free throw ratios for 3 basketball players are shown. So we can see player 1 shot 25 times and made 17. Player 2, 33 to 50. Player 3, 14 to 20. Now what we're going to do is rewrite each ratio as a number compared to 100, then shade the grid to represent the free throw ratio. So if we're taking a look at this, we can see we set it up as a proportion, but you can also see if we take that 25 and multiply it by 4, that gets us to 100. 17 times 4 gets us to 68. Okay, but if you're thinking about proportions like we've been going over, you can take 17 to 25 is going to equal a certain number over 100. Okay, so we multiply 17 times 100, that gives us 1,700. Then divide it by the 25, and that'll give you 68. Okay? So setting this up as a proportion is a really good way to figure out how to take that ratio and turn it into a percent. Remember, the total amount will always need to be lined up with 100 since a percent is always out of 100. Okay, so taking a look at the next problem, we see 33 to 50 is going to equal 66 to 100. How do we know that? Because when we multiply 50 times 2, that gives us 100. Then you got to multiply 33 times 2 as well, giving you 66. Next one, 14 to 20. Multiply that 20 by 5 gives you 100. 14 by 5, that's going to give you 70. Now, what we can do is fill in these 100 grid charts to represent the percentage. And I'll have you do that now. Now your different grid should look just like mine, so you can see 68%, that means we fill in 68 out of 100 squares, 66%, 66 out of 100, and 70%, we fill in 70 out of 100. Now from this, we can easily see which player has the greatest free throw ratio. We can see player 3, 70 squares out of 100. So we can write player 3 down. This answers the question, how does this show on the grid? You can see it's the most shaded squares. And we'll write this down too. All right, now letter C, it says use a percent to describe each free throw ratio. Write the percents in order from least to greatest. Okay, so you can see that we have 68 squares out of 100. So remember, percent always means it's always comparing to 100. So that's 68%, 66%, 70%. So writing these from least to greatest. Easy to see, 66%, just because we put a percent sign doesn't mean it's any different. Okay, 68 is greater than 66. And then finally, 70% from least to greatest. And now the final question, letter D, it says, how did you determine how many squares to shade on each grid? So we write equivalent ratios whose second term is 100. Okay, so we can see that right up here. The second term is 100. The first term tells how many squares to shade out of 100. So 68 to 100, shade in 68 squares. 66 to 100, shade in 66 squares, and so on. Now let's turn to page 205, and it says, talks about here using benchmarks and proportional reasoning. Okay, so it's important to understand that you can use certain benchmark percents to write other percents and to estimate fractions. So, for example, we have these benchmark fractions here and also benchmark percents. And when we talk about this, this is something that if you're ever estimating, you usually use these benchmark fractions or percentages. So in other words, if I were to say how much of your homework do you have finished, you would not say, well, I have about 13%. Nobody really talks that way. So if you're saying what percentage of your homework you have, you may say, I have about 10% of it, or maybe 1/10 if you're talking about as a fraction, or maybe you have about a half of it finished, or 50%. So these are what we call benchmark percents, and they also equivalent to fractions as well. So these are just some of the common ones that we're aware of. And that's what it means when we talk about benchmark percents. Okay, so when we're trying to figure out what a percentage is, for example, let's say we know 1/10 is 10%. All right, so if we're trying to find an equivalent percent for 3/10 or 3 to 10, we could see we would write it as a multiple of benchmark fractions. So we know that 1/10, okay, think about 3/10 is equal to 3/110. Okay, and then 1/10 is equivalent to 10%. All right, we can see that in step 2. All we would need to do is multiply. We know that 1/10 times 3 will give us that 3/10. Therefore, 10% times 3 would give us that 30%. So we can use that benchmark fraction or percent of 10% and figure out what 3/10 or 30% would actually represent. So let's look at page 206, and it says use a benchmark to find an equivalent percent for each fraction. Okay, so what we see here, we have 9/10. Okay, and we think about that benchmark fraction of 1/10 is equal to 10%. So if we have 9 of these, that means we would need to multiply that 10% times 9, because we would know that there's 9 1/10 and 9/10. Okay, so thinking about 1/10 times 9 is going to give us 9/10. Therefore, we take that percentage, multiply it by 9, and that's going to give us 90%. So 9/10, just thinking about that, gives us 90%. Again, this is just one strategy that you can use. 2/5. So what we do is we think about 1/5. That's going to equal 20%. And we know that if we take 1/5 and multiply it by 2, that's going to give us 2/5. And then we take that 20%, multiply it by 2, and that's going to give us 40%. So looking at number 4, it says 64% of the animals at an animal shelter are dogs. About what fraction of the animals at the shelter are dogs? So we can take a look at that those benchmark percentages and fractions on page 205, and we can see that 64% is very close to 66 2/3%. And we know 66 2/3% from that chart is equivalent to 2/3. So when we're thinking about 64% and about what fraction of the animals at the shelter are dogs, we would say about 2/3. We can write that in there for question 4. So again, when we're talking about benchmark fractions and benchmark percentages, we don't really speak in terms of 64% necessarily. We would usually say something about 2/3 of the animals at the shelter are dogs. So let's take a look at some questions on page 207. It says shade the grid to represent the ratio, then find the missing number. Now, again, what we could do is if this is already set up as a proportion, we could take 23 times 100. That's going to give us 2,300. We divide that by 50. That's going to give us that 46. Or we can just see that we multiplied 50 times 2 gave us 100. We've got to multiply that 23 times 2, giving us 46. What you'll want to do is shade in 46 squares to represent that as well. Now for the next one, number 9, 11/20 is going to equal 55 over 100, representing 55%. Again, shade in 55 of these squares to represent that as well. Now, let's take a look at number 10. It says Mark wants to use a grid like the ones in exercise 1 and 2 to model the percent equivalence of the fraction 2/3. How many grid squares should he shade? What percent would this model show? So we know that 2/3, looking at the benchmark fraction and the percent that goes along with it, is going to be, first of all, how many grid squares? 66 and 2/3. Okay, so what percent would his model show? It would show 66 and 2/3 of a percent is what that model would show for question 10. Taking a look at the ratio, number 11, it says the ratio of saves for a baseball pitcher to the number of save opportunities are given for 3 relief pitchers. Write each ratio as a percent. Order the percents from least to greatest. So what we can see here is we have 9/10, or 9 to 10. It's going to equal a certain number over 100. Remember, percents are always out of 100, so we take the total, and then we got to figure out the number, the missing number here. So we take 9 times 100. That's going to give us 900. Divide that by 10. That's going to give us 90%. So 9 out of 10 is going to equal 90%. So setting up as a proportion is a way to do this. Or what we could think about is remembering that, I'm going to write it up here, that 1/10 percent or 1/10 fraction equals 10%. And we got to multiply 1/10 times 9 to get 9/10. Therefore, we would multiply the percentage by 9, giving us 90%. So that's another way to do that one as well. So I will erase this work here, and I'll show you the 4/5. I'll show you the other way. If you remember, 1/5 equals 20%. And we know in order to get to 4/5, we multiply 1/5 times 4, and that's going to give us 4/5. And since we multiplied that 1/5 times 4, giving us 4/5, we have to multiply that 20% times 4, and that's going to give us 80% there. So 4/5 equals 80%. Now let's take a look at 17 save opportunities out of 20. Not too bad there. So we take 17 out of 20. That's going to equal something out of 100. Should put an X there instead of the box. So something out of 100. So first step, multiply. Since we set this up as a proportion, we cross multiply 17 times 100. That's going to give me 1,700. And we take that 1,700 and we're going to divide it by 20, by the other number we did not use. And that's going to give me 85. So 85 out of 100 means this represents 85%. So 17 out of 20 equals 85%. Now what we need to do is order the percents from least to greatest, not too difficult here. So we have 80%, then we have 85%, and then we have 90%. Okay, so now thinking about our percentages, our benchmark percentages and fractions that we talked about earlier in the video, we're going to take a look at which quantity would be greater. 1/3 of a box of corn crinkles or 50% of a box of corn crinkles. We know that 1/3 is about 33 and a third, not about, is 33 and a third percent. So therefore 50% of a box would be more. Next one, 30% of your minutes are used up, or 1/4, which is equal to 25% of your minutes are used up. And we can see that 30% would equal a greater quantity there. So this concludes the video for understanding percent. If you have any questions about this concept, please come and see me.